Hello, my name is Marcus and I'm learning Rust by going through the Project Euler problems. Today we're on problem number 15. 15 is trying to find how many routes from a grid. So going from the top left corner of the grid to the bottom right corner. They give us an example for a 2 by 2 grid, and then we need to solve for a 20 by 20 grid. So the way we can go about this is at any given point, we have two directions we can go. We can go either right or we can go down. Then you're starting at another point. Then again, you can go right or down. Then you get to an edge. In this case, we'll get to an edge. So we go here to the right, and we go to the right then, and then we'll get to this initial path. And once we get to an edge, there's only one route you can go. You can only go straight down to the end. So what we want to do is calculate, kind of do a recursion for each time you go to a new one, launch again, and then launch again. And then once it gets to an edge, there's only one route to that path. Hopefully that makes sense, explaining it and talking it through. Kind of work it out and think about it, because this one, I don't think there's going to be too much code. It's going to be more just thinking about how those paths can be walked. So let's dive in. I've already stubbed out our problem. So what we want to do, let's start a test. Our test will be, we'll just test, we'll calculate this route. And then it will be, we'll just do the simple example of a 2 by 2. So our calculate route function, we actually want to do each of those. We want each of those points, right? So we want an X and a Y, because then an edge will be defined if one of those is at a 0. Right. So what we'll do is that top left corner, the top left corner will be 2, 2, and then we'll subtract as we go till we get to a 0, and then there's only one route to go. So let's, so a 2 by 2 grid should give us 6. So let's write our function. So we want an X and a Y, and we're going to return our count. So for our edge, if X is 0 or Y is 0, that's our edge. There's one route to go to get to the bottom. Otherwise, we want to return we're going to go to the right, so X minus 1. And then we want all the routes that also go down, which will be Y minus 1, right? Y minus 1. And I think that will do it. I think that is pretty much the code. It's not too much. Run that. Our test pass. Hopefully that makes sense. All right. So each one of these recursion steps, we're going to go to the next point, and then it's going to do the same thing again. It's going to go to the next point, and it's going to do the same thing and do. It's going to generate a lot of work, because it's going to go to every single point and calculate those routes as it goes. But it's a computer. It's got nothing else to do. It can generate some work. Our routes will be, the only problem will end up being if this, I think it'll probably end up being a little bit slow, but we'll see. A 2 by 2 grid has that many routes. And so then it'll be size by size has that many routes. Let's run that. All right. 6 by 6 grid has 924 routes. I did the wrong thing. 2 by 2 grid has 6 routes. That's right. We did 6. We can do 10. The 10 by 10 grid has 184,000 routes. Let's see how, we won't go up to 20 just to give away the answer, but we'll do 18, which is pretty close. And it looks like that is kind of slow. One thing you can do, if something's going slow before, you can do a release build. So if you do cargo build release, it'll give you an optimized binary release, and then you can run that and see how it'll make it quite a bit quicker. It's a good first thing to try if the program's slow. You don't want to have to rewrite it. The caching part will be a little bit tricky, because we're doing caching with recursion, so we'd have to rewrite. So that wasn't too quick at all. It's probably like 20, 30 seconds. The caching with the recursion, we'd have to rewrite. We probably have to write this counting up to our number, and then we can cache at each point. But it'd be a little bit trickier to do it since there's not really a global or anything like that. So it worked out. If we were doing like a 100 by 100 grid, we'd have to probably rethink this, but 20 by 20 wasn't too bad at all. So that was problem 15. I hope it was good. Thanks a lot. Cheers.